This lesson is polar coordinate part 4. So the last video was changing polar equation to rectangular equation. So now the reverse, rectangular to polar equation. Okay, so here we have an example for xy equal 9. Note, y is always r sine theta. X is always r cos theta. Okay, so be very careful. Y is always r sine theta. X is r cos theta. So replace y and x with these trig identities. Okay, so x is r cos theta. Okay, and then y is r sine theta. Okay, again, just replace them. Okay, again, be very careful of the identities. Okay, now all we need to do is just multiply them across. So 4, just 4, r times r is r squared, and then put sine first and then cos after. Okay, next we're going to split this 4 into 2 times 2. Okay, and then we're going to separate this right here where I am circling. 2r squared, 2r squared, put that in front. Put the 2 sine and cos together as 1. Put the 2 sine cos together as 1. And here's the reason. According to the double angle sine identities, sine double angle is 2 sine cos. Okay, sine double identities is 2 sine cos. So replace it. Replace 2 sine cos with sine 2 theta. Okay, and this is the answer for polar equation, which is the same as rectangular equation. One more time. This is rectangular equation. This is polar equation. Okay. How do I know when to stop? When there's nothing else you can replace. Okay, so there's nothing else you can replace here, so that's when you stop. So polar coordinate is to the answer to this rectangular coordinate. Polar equation is the same thing as rectangular equation. They are the same graph, just different writing. Okay, so this is the answer to this. Polar equation, rectangular equation, same graph, just different writing. Okay, so be very careful. Know when know what identity to use and replace. Okay, know what identity to use and replace. Okay, and most of these identities are listed in the PowerPoint. Okay, so you have to go back to these PowerPoints, or you can just search it online. Okay.